cool. Okay, so hi everyone. Thank you for coming to my talk. This is introducing the Office 365 attack toolkit. So let's continue. Who am I? My name is Sherri. I work as a senior security consultant at MDSec, where I'm responsible for performing red team operations of pen test services and other interesting offensive security stuff. I'm also interested in low-level research like Windows internals, playing with reverse engineering, and also with exploitation. On my free time and company time as well, I develop offensive security tools, and you can find more about the tools and research we do at our blog or follow me on Twitter. So yeah, so what is this talk about? During our red team operations, we frequently come in contact with organizations using Office 365. And usually when we did the operations, all the time we had to develop tools because the tools that were publicly available were somehow limited. And that's why we decided to create a new tool, the Office 365 Attack Toolkit, that we can use during operations without the hassle of going to modify and develop new tools. So in this talk, I will explain all the features this tool has and how it can assist you if you're performing a phishing simulation or red team exercise. I'll also visit authentication token phishing, what it is and how it works. And then we'll take a look at the Microsoft Graph API, how we can use it for our purpose. And as a bonus, I will talk about something interesting I found on Azure CLI. So, what is Office 365? As probably many of you know, Office 365 is a line of subscription services offered by Microsoft. Essentially, it allows companies to run the Office suite as a cloud-based software service. And it allows you to run that without the headache of managing hundreds of different Office versions across your entire environment. And it's also safer than the average company deployment. That's because it auto-updates, obviously, but also some of the features that are usually exploitable on workstation laptops are not available, like, for example, macros. And even if you have like a 0-day forward, if they are using Office 365 Web, the document is not actually parsed in the user Word application, but on the web, so it won't affect it. There are some ways to get around that and trick the user to open the document on their local computer, which I will talk later on about. So yeah, that's all about Office 365. If you want to read more, you can just go on Google and find as much information as you want. The other part of this talk is the Microsoft Graph API. So essentially, the Microsoft Graph API is a developer's API platform which allows developers to integrate their applications with the Office 365 products. For example, to integrate with Word, OneDrive, SharePoint, you name it. So this is built on top of Office 365, but it's not actually limited to Office 365. So for example, if you are a company, you want to create a bot that sends and receives emails, you can easily do that because the Graph API allows you to interact with Outlook and to access the user emails, to send emails as the user, and many other features. Also, let's say you want to make an antivirus for the cloud, for your cloud environments. So, for example, for the files that are on OneDrive or SharePoint, you can easily do that. You can just call the Graph API and access the files that are there like a proper file system. So as you can see from the two examples I gave, there are many, many more features, but only from these two examples you can see that this API is like really, really powerful. And when something is really, really powerful, it leaves also room for abuse. So that's what the tool does. But first, to call the Microsoft Graph API, you first need to have the authentication token, an access token. So basically, the access token is a token that is provided to you by the Microsoft Identity Platform, and it has the permissions that the user granted you. I will talk later on about how that works and what the user gives you for permissions. But first I want to revisit authentication token phishing. So what is authentication token phishing? Authentication token phishing is not your traditional phishing where user enters his credentials to a website and then you steal them and then you can use to perform operations. In this case, the credentials are entered in the legitimate Microsoft website. So when the users are trained to are trained to not enter the credentials on malicious website, this thing gets around because literally they're entering to the legitimate Microsoft website. And also, this is really useful as well because recently we have seen a rise on multi-factor authentication. And if the user is using multi-factor authentication, and let's say use something like EVANGEX to retrieve the username, password, and token, you're like really time limited on what you can do, so you need to log in immediately, otherwise the token will not be valid anymore. And this thing gets around it because when the user grants you the permissions to perform actions on its behalf, you don't have to use anymore the token because you're literally just performing actions. So yeah, this is in itself is not something new. The first publicly documented attack was by APT28 on the famous DNC hack, when they abused the Google Auth to actually compromise. I don't remember the name of the politician, but to compromise his emails and then leak them to. Sorry? Yeah, and to leak them on the internet or WikiLeaks. So yeah. So now we have a good understanding of all the, let's say, the methodologies this tool uses. So what is Office 365 Attack Toolkit? So Office 365 Attack Toolkit is a tool developed in Golang, which allows operators to perform authentication token phishing. And then after getting a valid access token, then it will start to call the Microsoft Graph API and use the acquired permission that the user granted to perform actions on its behalf. So there are currently the current supported features are the extraction of emails matching specific keywords, the creation of malicious Outlook rules, extraction of files from OneDrive SharePoint, and the macro injection on Word documents. So I will talk a little bit more in details of how we can use these features to actually be useful in when you're performing a phishing assessment or something similar. So the first feature is the extraction of emails using predefined keywords from Outlook. So let's say that usually, as you may know, people on email usually store a lot of confidential information, including username and passwords, confidential user data like attachments, or we have seen cases even like containing passwords, spreadsheets on their email. So what you can do is you can define specific keywords that this tool will search the user email box, and for every mail that matches a specific keyword, it will download them and save them, and then you can later on investigate all the emails and see all the contents. So another interesting one is the extraction of files using predefined keywords from OneDrive SharePoint. So this works the same way. You just define keywords, but in comparison with the download of emails, this actually downloads the files. So for example, if the user has uploaded an SQL file with all the customer credentials, you can like specify the .SQL keyword, and then it will download all the SQL, say, files. Or if the user has a password spreadsheet on his OneDrive or a key password database, so you can do that. You just specify the keyword, and when the user grants you permission, the tool will search all the files that the user has, download all the ones that match the keywords, and then the attacker, or us in this case, can just like use that information to further compromise the environment. So the other one, and this is quite interesting, is the creation of malicious Outlook rules. So as you may know, Outlook has a rule engine which allows you to perform actions when a specific event happens. And this is really useful for us as well as attackers, because we can come with really good ideas, creative ones. So, for example, you can create a rule on Outlook that will forward all the emails containing sensitive information to an attacker-controlled email address. So, for example, if you create a new rule and say if it has an attachment and it has the keywords like top secret or confidential or passwords, then it will send that when the email comes from whoever, that it will send that email to the attacker-controlled email address. So even if you have lost access, and the rules will probably still be there because no one looks for the Outlook rules, and then you get the data. So even if you literally don't have any more access, but you still keep receiving confidential data about the client. So the other one is the forward of password reset emails. So let's say the user is using a third-party system to and is signed up with his work email address. So what we can do is create a rule that says if there are any password reset emails, let's say if it contains the word password and reset, then forward all these emails to an attacker-controlled email address. So in this case, you just go to the third-party service, issue password reset. The email with the password reset information will be sent to the user, but then also after sending, because the rule is there, it will parse this email and also send it to the attacker. And in this case, you just literally gained access to a third-party service without even having access to the user email anymore. I didn't know this feature, but apparently Outlook also allows you to create rules based on outgoing emails. So in this case, you can create an email rule that will prevent the user from reporting something suspicious is going on with their PC to the IT security team. So yeah, this is about Outlook's rule creation. And let's go to the Word document macro injection. So this is actually my favorite feature of this tool, as it allows you to inject a macro on the user OneDrive, a macro on the user Word documents that are stored on OneDrive. So if this tool is, if this feature is enabled, what it will do is retrieve the 15 last access documents on your the attacker machine, inject the macros that you previously defined on the configuration file, and then it will upload them on the OneDrive and replace the original file. So you may ask, okay, you defined a macro, but you previously said that the macros do not work on Office 365, which is true. And then we come back to the interesting part. So apparently Office 365 does not support Word 2003 documents. So what you can do is, if you change the file extension of the file from docx to .doc, then Office 365 will not parse it and will say to the user that you need to download and open it locally, which is really useful. And since the document in itself is the original and is literally something that the user thinks is private, it's way more trusted than something that comes from the internet, and your chances of actually the user enabling content and executing the macro are really high. So yeah, that's all about the Toolkit feature. I will also get a walkthrough on how to deploy it properly, but first we need to understand the components this tool is made from. So there are three main components. The first one is the phishing endpoint, which serves the phishing page to the user, and this is responsive. And the other one is the backend service, which is responsible for performing all the attacks. So this retrieves the access token and then does all the defined attacks, like the extraction of emails, extraction of files, and the injection of macro documents. And then we have the management interface, which is pretty clear by the name as well, which is used to inspect the extracted information that you got from the user. But how would the proper architecture look like? So this is the suggested deployment. And as you can see, there's like the attacker infrastructure, which is constructed by two servers. The first one is HTTPS redirector, which redirects all the traffic to our external server, which is the phishing endpoint. Then the host running the toolkit, the backend service, will call the Microsoft Graph API, perform all the attacks, and then we as an attacker can use that the management interface to inspect all the data. So I will get back to why we need to use like such an isolated architecture later on. But first, let's see how we can deploy it. So there are three main components on the configuration file. They are the server, keywords, and the backdoor. So the server component contains 5 options, which is the host, the IP address of the external listener or the phishing endpoint. We have the external port, the port where the phishing endpoint will listen to. And then we have certificate and key, which are the public certificate and private key if you want to use HTTPS for your phishing endpoint. And then we also have the internal port, which is the management interface. As you can see, there is no host for the internal management interface. This is because it only listens on the local host. Then we get back to keywords. So we have 2 options here, and they're quite similar, but they do different things. So in this case, I've defined 5 keywords that I want to extract from Outlook emails, which are paths, VPN, creds, credentials. And then from OneDrive, we do the same, and we extract a password file, the files containing the word password, the files containing .config or XML or database, which are usually the files that have confidential information on it. And then the third option is the backdoor. We can enable or disable this, and the macro is the file path of the macro document you want to inject. So it should be mentioned that the backdooring functionality on Word works only on on Windows, as Windows is it's essentially how this injection works is it uses the word.com object to open the file and then inject a macro. So yeah, now that we have a proper configuration, we need to go to we need to create an app. Because to call any Microsoft Graph API resources, you have to have an app registered on Azure. So you can easily do that. You just go to Azure Active Directory, app registration, register an application, and you can define the name that you want. So in this case, I just called it Cool App, but you can change the name that in whatever matches your pretext when you're doing the phishing. Also, just keep in mind to select the accounts in any organizational directory, because if you don't select this one, you can only attack or let's say phish users that are on the same organizational directory, which is not really useful, but in some cases is. Okay, so you created the application, you get the application ID, and then you change it to static index.html, and then you add the redirect URL with your phishing endpoint. So basically, the redirect URL is used by Microsoft when they send the access token. So this is your phishing endpoint, and it has to be correct because otherwise it won't work. Also, because the current implementation is just a single web app, JavaScript app, you need to enable implicit grant because otherwise it won't work again. So yeah, so by default, the phishing endpoint is not pretty and not useful, and I'm really bad at designing. So, but I also left it on purpose because I don't want to provide people with a full template which they can just like straight away use to phish other people. So, but it's fairly easy to modify. The HTML file is hosted on static index.html, so you can just change the static index.html file, insert, change the HTML file on whatever the pretext is, and then you're good to go. So now you configured the tool, you changed your phishing HTML file, you created all the Outlook rules that you want, and then you're ready to go, right? Well, as you may know, with any tool that you run on your system, like being the defensive tool, being the offensive security tool, there is always some room for some other people to attack. There's always an increase in attack surface. So in this case, I wanted to talk about some of the attack surface, which is not, let's say, really dangerous, but at some point it may be if you do not do things properly. So the macro injection functionality is kind of dangerous in this case if you don't do it properly, obviously, because the way it works is it downloads the user files and then stores them on your attacker machine, and then uses Word.com object to actually open the Word document and inject the macro. So in this case, if you're running an old version of Windows and you're running the tool on your main box, then things can go really wrong, because if the file that you downloaded that matches that specific that has been used by the user actually contains a macro or exploit or some exploit code that targets a version of the Windows Office that you're running on your box, then things may go wrong. So it's always important. That's why I suggest on the architecture to have a proper isolation between the hosts, and to also use an updated Office, because even us as attackers need to use updated software, otherwise we will get popped. And then is the extraction of keyword files may bring danger. So this is not really dangerous, but we have seen cases that when you download, like, just by a file being present on the file system, it can trigger like some exploit. So we saw that with Stuxnet, where it's just like an LNK file will trigger command execution. And then we also saw the same recently with Linux. There was like a KDE command injection bug. So yeah, you need to be made aware of all the dangers that this tool has. So as I said, I'm saying this if from a perspective where an attacker is trying to attack the attacker. I mean, it probably won't happen in your lifetime, but it's good to know. And also, as I mentioned, as we also suggest to the defensive part of security, we also need to properly isolate, configure, and manage the infrastructure securely. So yeah, that's all about the Office 365 Attack Toolkit. I still have not finished. I'm going to do a quick demo. Oh, okay, so I'm pretty sure it's not really visible. Or is it? Yeah, it is. Okay, so as you can see, we have a Windows VM, which is running the toolkit. You can see that it says loaded one rule successfully, because I defined one Outlook rule just to demonstrate the feature. And then we have the internal server and the external server, both running on the local host, as this is just for demonstration purposes. So yeah. So this is our user that is going to get phished. So he has two documents, the business partnership document and the password document, which is kind of funny because sometimes users just put the password on Excel spreadsheets. So yeah, just keep in mind the extension is actually now .docx, because it will change later on. And then we have an email which supposedly contains some credentials. This is also just to demonstrate. And then as we can see, there are no inbox rules on this user. So yeah, so this is the best looking phishing endpoint. I'm pretty sure everyone will fall for it. So when the users click sign in, actually Microsoft not signing page, but Microsoft page pops up, and it says to you that this application is trying to request permissions, and my application in this case name is "This is a legit app," which is not. But you can change the app to match whatever pretext you are using to do the phish. And as you can see, they are pretty clear what the app will access. It says it will read your contacts, read your email, read all OneNote books. It can read all your files and everything, but the user will still click accept because that's the blue button and it looks cool to click it. So after the users click accept, it's actually game over. At this moment, we get like the access token, and then the backend service is actually performing all the attacks on the backend. So this is the management interface. We'll get back to it again, but let's see if like our attack worked. So we can see there was no rules defined, and then refreshing the page, we can see that there is a new rule. There's like the example rule that I previously defined that will send all the attackers, all the password reset emails to the attacker. And then, as we can see, the documents the user had has just been changed, and also the file, the extension has been renamed from docx to .doc. So when he tries to open it, he cannot edit it, and when he downloads it on his box, okay, let's wait, and opens it, it's like literally the same document that the user had. So he enables editing because protected mode is enabled, and when he clicks enable content, then our malicious macro got executed. In this case, it's just a message box, but can be whatever you want. Then we can go to the management interface. We can click view emails and see all the emails that have been extracted from this user. You can see a body preview of the emails, but you can also see the entire email called by clicking view email. Also, you can view and download and access all the files that were extracted from this user. In this case, only one file matched the rule, like the password.docx. But as I mentioned earlier, this is just for demonstration purposes. In real life, it's way more files than that. So that's the demo for Office 365 Attack Toolkit. Let's get back to the presentation. So, what is Azure CLI and why is in this talk? So, for those who don't know, Azure CLI is a command line tool which allows you to manage Azure resources and to actually automate the creation of Azure resources. And it's like really easy to learn. It's like quite powerful. So I was playing around with it, and then I figured something strange was happening. But before using the tool, you have to use the command ASLogin, which will open an Azure sign-in page, and you enter the credentials, and then it will just work magically. And I got back using the tool after 1 month, and then it worked. It didn't ask me for login. I was like, okay, there's something weird going on. So I just set it up again and saw the entire workflow of this tool. So essentially, it was starting a local web server and then sending the access token to the local web server, the access and refresh tokens, and then they were storing the access and refresh token on the file system in clear text. I was like, wow, that's not really good. So the access, there was a file named accesstoken.json which contained the refresh and token and the access token. So the refresh token is okay, let's begin with access token. The access token is actually the token that is used to access the Graph API or other API on Microsoft. But the thing is that this token by itself is not really useful. If you manage to get access to it, its lifetime is, I think, 1 hour. So not really useful. But then we have the refresh token, which its lifetime is, I think, 1 year or something like that. And then this token can be used to get new access tokens. So if you have the refresh token, you just can retrieve new access token and call the Graph, the API that you want. So this is really useful because, as I mentioned earlier, a lot of users and admins are using 2FA or MFA. But the problem is that when you grant access to an application, the application doesn't have to use the MFA anymore. It can just straight go and call the API they want. So I did a tool for this called Azure CLI Extractor. I still haven't published it, but I'll publish later on my GitHub. So basically what this tool does is extracts the access token and the refresh token, and then it can create a new global administrator on Azure and Office 365. And because this tool is mostly used by, let's say, system admins and like IT people, generally they have more privileges in privileges in Azure and like the Office 365. So yeah, that's so we can use that even if they have MFA. We can use that to get around it and like compromise their cloud environment. So I also have a demo for this one, which is way easier to explain rather than just talking randomly. So let's suppose we managed to gain access to some user machine and we got his username and password, right? So cool. Now we just completed our red team objective. We go to sign in, we enter the password, we try to sign in, then, nope, not so fast. So there's like, this administrator has 2FA enabled. So we either have to compromise his phone or find another way around it. We don't want to spend millions on compromising phones. We're not Saudi Arabia, Prince, but so fortunately for us, this user has the Azure CLI Toolkit installed. So what we can do is use Azure CLI extractor and call the command .user. Then we can define the options like the display name, which is demo user, the username, which in this case is compromise. And then we also have to define the account principal, which is, let's say, not the email address exactly, but, and in this case is compromise at azurecli.microsoft.com. And then we need to specify password, which you need to also have it to match the password policy for Office 365. And as we can see, the tool did its job. It adds a new user and then adds that user to the global administrator groups. So we didn't manage to get access using the demo account, but then we just use the newly created account to log in. So we enter the email address, then we enter the password that we created, which is secure password 123. I changed it, so don't try to log in. And then we can see we managed to gain access to the portal. And as you can see, we also have administrator permissions. It's a bit confusing here because there are too many usernames when I was doing the demo. And then we log into the Office 365 administrator portal with high privileges, bypassing 2FA completely. So that's all about Azure CLI. So everyone is saying, okay, this is quite cool, but I work on the defensive side. And people will start using this to phish my users, and what can I do? So there are actually a lot of stuff that you can do. And I think Microsoft has one of the best, I'd say, tool to use that you can prevent all sorts of attacks. So the first one is you need to restrict users from registering applications. So basically, by default, any user on your Azure Active Directory environment can register your application. This is really useful if you're an attacker, because if you manage to compromise a user, then you can register your application, and the application will be from the same organizational directory, and it's like trusted. So when you send a phish to the user will see that, okay, so this is an application from our company, so it should be legit. And they are more susceptible to phishing attacks. And if you stop users from registering app and also only allowing administrators to do so, or developers, you will prevent this kind of attack. Also, if you don't use any third-party apps, you can entirely disable them, which is what most people do, hopefully. And then, if you see that an application compromises one of your users, you can revoke the permissions that this application has, and also notify the user. And you can, if you are doing like an incident response for this kind of compromise, there is a feature called auditing on Microsoft, which essentially provides you the comprehensive monitoring of all the activities performed by the application. which is quite useful, and I think every system that uses some kind this architecture should have it. And also on the Cloud App Security portal, you have you can define alerts. So, for example, if an application gets permission to a user mailbox to read all the emails, it's not like really how it should work. So you can alert and check if that application is legitimate or not. And also you can search for risky apps using the same portal. So, for example, there are a lot of queries, but in this case, it's searching if any app has requested these permissions from the user, which are read and write access to user email and full access to the mailboxes and other stuff that is not normally used by a legitimate application, but is used a lot from attackers. And also, I was quite surprised. I saw on a news portal that apparently Facebook is improving, and they are now notifying users wherever a third-party application actually log in. So let's say accesses resources using the permission they were granted previously, which I think is quite cool and is the way to go. And I think also Microsoft should implement this, because currently, as far as I'm aware, the tools are only targeted to the admins. So let's say if you want to investigate what happened, you cannot see when the application got access to a specific resource or what happened. Only you as an administrator can see it. So I think Microsoft should also implement this, that whenever a third-party application access resource, they should notify the user. It doesn't have to be an email, but you can notify the user that, look, this application just access this resource, and then the user will be more aware of what the application is doing on the back. So yeah, that's about mitigations. I want to talk about also some references. So there are a lot of cool stuff going around currently on the offensive security side. And if you're not following him, you probably are, but if you're not, you should follow him. Dirjan is putting out some really amazing research, not only for Azure and Office 365, but Active Directory as well. Then there is another tool called PwnAuth from FireEye and DogSec, which has this kind of similar approach, but it's more targeted just for proof of concept rather than fully weaponized. I also wanted to mention MassiveScale.com, which is quite useful and explains all this Microsoft Cloud stuff really well. And as always, the site that I spend most of my life in is docs.microsoft.com, which contains all the information about the Graph API and any kind of Microsoft products. So yeah, I think I'm quite ahead of time, which is cool. So we have a lot of time for questions. Anyone has any questions? Yep.
Just to clarify, your Azure CLI, so you're relying on someone phishing a user to get into their account to create this Azure app. So
No.
Would you be frustrated if the user had MFA? And just to work, how do you get in first without the MFA?
No, so actually the way the thing works, so the case was when you're like on an environment, and let's say you're trying to compromise some administrator. And in this case, you're already on the environment, manage to get access to that file, let's say by either finding a backup or like on a network share, someone just shared like their home folder, and which is usually the case. So there are a lot of ways you can get to the environment. Like MFA is really helpful and it's really a headache, but then there are a lot of stuff that you can abuse to actually get around it. Yes? Yes. Also, like if you have some specific, I cannot recall correctly how you to do it, but I'm pretty sure there is like a way to only allow specific application from accessing user resource. You can even specify the application permissions. So, for example, if you want an app to only access the user information, even if that application goes rogue and says like, okay, I'm going to steal all the user emails, they can, because you defined previously that this application should only have access to this resource.
If you set up your application with all users' emails, and then you phish an administrator, could you, in effect, through that phish, be looking?
Yes. Yes, you can. So basically, this tool is more aimed at like users, but if you phish an administrator, then you can do a lot more damaging stuff. But this, in most of the cases, it's not really useful to phish an administrator because they are more trained and the way how like system work. But there have been a lot of cases where that happens. So. Anyone else?
Teams integration.
Okay, well, so I haven't looked at it.
Create open teams or something like that.
Yeah, I haven't looked at it, but maybe, I don't know.
It's not really useful for proof of concept.
Yeah.
Where are the best resources for learning? Is your CLI and stuff like that?
I think Microsoft Page, like, they literally have so many documentation and explain things in much detail. So I think the best place is Microsoft itself. Anyone else? No curiosity anymore? Okay then, thank you very much. Hope you enjoyed it.